Hi there, and welcome back to Test Automation for the Practical Programmer. For this installment, we will build off the previous video and show how we can use functions to build toward a cleaner set of reusable code tools. We'll spend the remainder of our time together in the coding environment and reusing a large portion of the code from the previous video, showing how I leverage wrappers around the core sockets-based methods to help simplify the usage. Let's start by copying the code from our previous example, creating a new Python script file named withfunctions, and paste the contents here. The first function I'll create is instrument_connect. What I'll use this for is to capture the first 4 sockets methods from the original example. Notice how I've created parameters to capture all the inputs I originally created variables for, so that I don't have to rely on globals. I've also included a parameter to hold an incoming variable that will eventually be instantiated as the sockets object and then get returned to the caller. It's debatable on whether or not this next function is needed, but I'm including it anyway. For examples I share with customers and colleagues, I like there to be a little bit of uniformity up front to help the code speak for itself. Here, I'll simply pull the close sockets method inside. Let's do a little bit of cleanup before we move on to our next function. To help conceal the need for adding a line feed character to every command that is sent, as well as the necessary data encoding, I'll create the instrument_write function. Note how I use an F string to format the incoming command string that is consumed by the socket_send method. The last function I'll define before we put things together and run the script is instrument_read. As you've probably guessed, I'll be wrapping the socket_receive method so the user doesn't need to concern themselves with the sockets_decode or rstrip methods. I'll still pass in the receive size as a parameter, and I'll return the data extracted from the instrument. Let's put it all together. I'll assign the return value from instrument_connect to the instr variable, which, if the instrument connection is successful, will hold our sockets object. Note how I'm reusing the variables I'd previously defined to pass in as arguments to my function. I then call instrument_write to send down the command asking for the instrument identification. Next, I'll follow this up with a call to instrument_read, and then print its return value to the console window. The last little bit I'll add here is the call to the instrument_disconnect to release the connection to the instrument. Upon running the script, we can watch the terminal window in the bottom of our screen update and report the information returned from our connected instrument, which just so happens to be a Keithley 2612 source meter. Let's now clear our terminal window and prepare for one last function definition and the rationale behind it. In the world of instrument automation, you'll hear commands that end with question marks referred to as queries, meaning that you are basically asking the instrument a question about its state. A query is nothing more than a command write followed by a command read. And what better way to show this off than by using the wrapper functions that we created to do both. I can then print the response from a call to instrument_query the same as I did for the instrument_read. Now when I run the script, I'll see the instrument identification printed twice in the terminal window. However, I can replace the initial write and read with the query and save those 2 original functions for where they're more appropriate. Join me next time where I take the comms tools just a little bit further. Thanks for watching.